Okay. All right. I guess I'm not going to do that. So sorry, everybody. Just going to kind of redo the notes as we're formally. We did some bell work at the beginning. Just pause the video and look at it. If you were absent, oop, there you go. Good math. We talked about the SAT next week. Could be some SAT questions. Factoring definitely going to happen today. And then we're playing polynomial, not a polynomial. So you can look at the answers for A. A is a polynomial. B is not. C, now this is not equal to, I get students do this all the time. It's like this. What's the square root of 9 plus 16? Is that equal to the square root of 9, 3 plus the square root of 16, 4? Or is it equal to, I have to add those two together because of order of operations and I get 5? And the answer is this one, not this one. So I know students hate when I do this, but you would not believe the work I've seen over the years of students doing crazy things like that. So this is not equal to 3x squared plus 4x. No way. You can't square root those individually. But that being the case, this is not a polynomial, and I'm moving on. So polynomial, for the movie purposes, reiteration for everyone at home right now, nice whole number powers on the x's, no negatives, no square roots on variables. So that makes letter D, yes, a polynomial. And the degree of it is 4. We have a 4 and a 1. The degree equals the highest degree of the polynomial. What's the leading coefficient? 15, because it's bigger. Wrong. It's -2, because -2 is in front of the leading degree term. Best way to describe that. And then what we're going to do on Wednesday, that dictates what the picture is going to look like, and you'll hopefully remember that from Math 3. What else do we have to say? Leading coefficient. Oh, I guess I could call it a binomial, though. I don't think they have anything for that. Did I forget anything? State the degree, leading coefficient. Is it a polynomial? Let's move on. Okay, some things. Oh, no, yes. Who is that? Yeah. Uh-huh. See, because this is not true, that I can't square root those individually. There's nothing you can do mathematically to that to simplify it like any better. Square roots on variables are not polynomials. Polynomials are just x raised to a nice whole number power with no other operations done to it. It's the best way I can describe it. Okay, so that's why letter C is not a polynomial, because what I wrote to the right was a lie, a fat lie. That is not true that you can mathematically do that. Students often try to do that, though. I hide this thing here. It's part of my video there. Okay, and then, all right, so we're in the polynomial chapter. Up through 2.5, we're going to really break down polynomials. So what are we doing in 2.1? Talking about our most basic ones. Hey, for the SAT, this might not be necessarily a bad thing. They really do like quadratics, and seeing if you know the basics of those. Just to keep this in line here, why is the constant function degree 0? Like, for instance, give me an example. F of x equals 5, and that's it. That's degree 0 because I could put, like in the previous thing I showed you up there, an x to the 0 next to it. X to the 0 is 1. 1 times 5 is 5. That is why this is considered degree 0. Very simple thing. Now, linear functions. This is on a YouTube video. This is the 17-minute thing I told you had to do on your own. Maybe just watch the beginning of this example and then move on, because it's really what we did in the bell work, but just looking at that notation. All right, you're going to want to write this down because I am calling on you. Your number comes up, you're ready to go. Ooh, I'll give the person who's up a heads up after I go through this note thing. Student number 5, Modest, you better be ready for my next question based off of these terms here that I write. Okay, I'm going to write this a little differently than they have this up here. We're going to first write quadratics and understand that there's 3 different forms that a quadratic can be in. The first one that I'm writing right above here is called standard form. The ax squared plus bx plus c. You might want to write that to the far left. Then maybe in the middle, and then the right, the two other forms. So you have these all together. So in red, I'm going to write, what do we have to know about standard form right below it? Hopefully you remember this. Okay, for standard form, the vertex x coordinate is a special little formula. Now, I'm going to be honest with you. When I write this down, this should spur a wrinkle in your brain. This should be something where you say to yourself, oh yeah, I remember that. I remember negative b over 2a is the way that I can find the x coordinate of the vertex. Comma, f of negative b over 2a just means plug in that number. So you just plug in whatever you get for the x value and plug it in for y. So that is what you need to know for standard form. Of course, this means the axis of symmetry, which is where the parabola cuts through right through the middle symmetrically, is x equals negative b over 2a, that same magic formula. So when I go to a question about this, I'll probably find this first, and then also know that that's the x coordinate of the vertex. So kill two birds with one stone kind of thing. And that's all I'm going to say about standard form. We're going to move on to what's called vertex form. You should know what this is from chapter 1. We talked about this as one of our 12 functions, and we talked about this h comma k as a right, left, up, down shift. So what really gets moved right, left, up, down? The vertex. So the vertex shall be called h comma k. H, the right, left shift. Remember, if it's x minus 3, it's 3 right. If it's x plus 4, it's 4 left on the inside. Comma k. On the outside, k is the same. If it's a plus 4 on the outside, it's 4 up. X equals h is the axis of symmetry. So the axis of symmetry is x equals the x coordinate of the vertex. Note to self that later in the week, wrong Friday is when I meet you guys, we will be talking about like intercepts. So there was an x-intercept form. I'm teaching Algebra 2 honors right now. Sorry, I was hoping. It's actually integrated math 2 honors. And we actually show the x-intercept form, which really does pertain to what we're going to be doing on Friday. So when you have these factors like this is why we're going to have to talk about factoring quite a bit. These are the x-intercepts, and that's all I want to say about it for right now. X-intercepts are p comma 0 and q comma 0. So have these three forms right in front of you, ready to look at. It's three different things that we can see a parabola be in, depending on what's given. So just that. And then I can take one equation and put them in all three of these different forms. Very simple to do. A would be the same in all three of those forms. Just remember I said that because that's what we're doing next. We're taking parabolas in one form and putting them in another. So just remember that the A would be the same no matter what. Okay, so who did I get? I forgot already. Let's check that calculator. Nice. Student number 5, Modest. First of all, Modest, when you look at this and you're furiously writing this down and trying to answer my question, is this perfectly in standard form, or do I have to make a little adjustment? Modest, are you there? Yeah, go ahead. Go ahead. Correct? Oh, okay, now I'm going to let you do this this way. We're going to rewrite this in vertex form by a magic formula. Then the next example, I'm going to show you another math thing that you're going to have to learn. But let's go ahead and do it this way. How do I find the vertex when I'm in standard form? Hint, hint, I gave you a magic formula. That's why I warned you to write your notes down. What's the magic formula to find the x coordinate of the vertex? Or the axis of symmetry? Yeah. So we're going to do the axis of symmetry, and x equals a negative b over 2a. What is a b? Sorry. Yeah, what number is it? Hey, it looks like b looks like 6. Look at, they almost look the same. Anyway, over. And then this actually equals negative 6 over 6. So the axis of symmetry is 1. So the vertex's x coordinate is 1, comma. All right. Good, Modest. Probably just have a little internet lag there. I think today it might be on my end. I feel like my computer is just, I don't know. By the time I get to 7th hour, it's just like lagging. 5th hour, it's like perfect. Student number 13, James. I haven't seen you, James. Where you at? There you are. James, when I get an x coordinate, input, output, how do I get the y coordinate? Absolutely. Input, output. That's why I've been saying it all year long. Happens so many times when you're talking about graphing and getting coordinates. Go ahead and evaluate that. What do I get for the y coordinate? Yeah. Oh, no, we're good. I thought we got some time. So what do you end up getting, James? I didn't hear you. All right, actually, we're going to have to reevaluate. 1 squared times negative 3 is negative 3. 1 times 6 is 6. Negative 5. So negative 3 plus 6 is what? What's negative 3 plus 6? We'll break it down. Ooh. And then 3 minus 5, or 3 plus a negative 5. There you go. Then I'm going to see if we can tie this all together with that little hint that I said, student number 28. Boom shakalaka, Julia. Now I'm going to go to green because I had vertex form in green up in the notes. Now write this in vertex form. F of x equals. Hold on. Remember what I told you about A, though? Did you just fumble something? What happened? Remember what I told you about A when you toggle with... Sorry, I missed you. So, yeah, so what is A in this one then? Yeah, there you go. Sorry, I think there's like, I think we got some speed issues with the internet. And we're... Okay, then go ahead. I'll be quiet. Nice. Awesome. And then we know that the vertex is 1 comma 2. So if I were to snap a graph of this real quick, hey, and I'm going to do this on this one, give you some hints about, what if they gave you a picture of a parabola and you had to come up with a equation, vice versa. Hopefully you can do that. 1 comma negative 2. This goes down because it's a negative 3 in front of there. And I'll tell you what you can do with that 3. 3 makes it, stretches it vertically. For a parabola specifically, how you could graph it is go 1, 2, 3, and then 1 left, 1 right. That's what that A value actually means for the first set of points after the vertex. You could go ahead and plug it in, input, output, or I could look at standard form. I tell my math 2 students, the standard form actually tells you what the y intercept is, 0 comma negative 5. So I put the 2 forms together and I can also get a picture of this, but you should know how to take a sketch after you get in vertex form. And I think that's a good thing to cover with you. All right. Now I could do the exact same thing for this one, but you must know how to do what's called complete the square. So student number 7, we're going to talk about that together. 6 is Lucas Frank. 7 is Nadia. All right. So Nadia, are you ready? Go ahead and put your mic on. Now, I guess I'm going to put this in words over here. This is how you complete the square in this one. Step 1, we're going to put this in words, and you're going to want to write this down, especially if your number. What just happened? Am I still presenting? Someone turned their mic on. Oh, no. Oh, so the connection was lost for some reason, and I think my video is still going. There is something going on today. I have a horrible internet scenario going on here. Am I even screencastifying? I don't even know. This is a disaster. Okay, so let's try to go back in the call. I got 13 minutes left. This is fun. This is good stuff. Try it again. This is all live, by the way. Yeah, every time, 7th hour, things just get glommed up. I just can't. Okay, join. I didn't give up. Hey, I didn't give up. I just heard that. I'm back. All right. I know. This has been a horrible day today. Okay, do you guys hear me now or no? Well, now you shut up when I get back on. I just heard you guys talking. Hopefully nothing bad happened. Man, I don't know what's going on. I'm still struggling to get going here. Ah, got it. Okay, let's see. Oh, goodness. I am muted. Okay, you hear me now? Oh, sure. You guys were all talking when I was gone. As soon as I get back on, you all shut up real quick. I heard that. All right, fine. Okay, this is still live. I'm still taping this so you can show your family like what's going on here. Am I still in the other one too? Oh, this is all jacked up. Maybe I'll close this one, I think. And then this one's on. Oh, no, I got out of it again. Oh, geez, this is all jacked up. I'm out again. This is a disaster. This tape is going on YouTube. This is what this is all about. Oh, geez, now I just hit my email. I can't even function right now. Okay, so it's Google Class. We got 10 minutes. Disaster. Taking forever. I guess I have to restart my computer every time before. Okay, turn my mic on, turn my camera on. I'm back. Now I hear myself directly. No, it was not. It doesn't say I am. Oh my God. Good thing I didn't swear. Or did I? Now I hear myself as well. It's like, and it's delayed. So in my second one, I hear myself delayed, but I don't see it open anywhere. Let's see. Okay, so I see that one. Maybe this meet. Maybe I'm in twice. Gone? Gone? Oh my gosh. Am I gone again? Oh, this is going to be. So I'm screencastifying. What the heck is happening? So if you still hear me, there is nothing that shows I am in a Google chat right now. I cannot hear you at all. There is something like that I'm in one that I'm not in. So I'm going to go in one more time. That's getting closed. Oh my gosh. Okay, so tell me if you heard me that whole time because I'm going to join right now. And if you are still hearing me, that is impossible. Did you still hear all of that? Arrgh! Okay. Okay, here we go. Let's try this one more time. Do you hear me now? Oh my gosh. I'm putting this on YouTube. This is like going in exactly as what has happened to me right now. Because yes, I'm very frustrated. Okay, deep breaths. Oh, and then I get to go to my 3.5 hour meeting immediately after this that I told you about. Okay, let's see. You know what? I'm just gonna go to the notes and just hope for the best and finish this off. Nadia, you got lucky. I think you have something to do with this, though. I think you sabotaged the system so you didn't have to answer a question. That's what I'm sticking with. Okay. All right. So we're going to do a process called complete the square that no one could probably care less about right now after all my problems. Yes. Huh? What? Oh, for gosh sakes. Thank you. So I don't even know if I can. I'm so nervous right now. Oh god, I don't even know how to do it right now because it's actually not doing the thing that I'm allowed to present. Oh my goodness. I can't even. It's like, you know what? I don't think I'm in charge of this meeting. I don't know. Oh, there it is. Finally, it came up that I can present this. Okay, give me a second or a minute or 3 minutes or 5 or 10. There is obviously something wrong after I go through 5th, 6th, and 7th. By the time I go to 7th, my computer is just like lagging. Tell me when it presents, whoever said you have to present. What do I have left? 5 minutes? Great. 3-hour meeting. Oh, they're going to hate me in that meeting. My entire screen. I think I've hit that 3 times now. Waiting, waiting, waiting. I'm going to keep going after this, taping the next example. You might want to watch the rest of this disaster of a movie. Okay, so you can't see the movie itself can only see the screen here. You can't see what I'm trying to present on another screen. I'm having a Google nightmare right now. Oh, for gosh sakes. Then Alima's got to take the test today. Goodness gracious. Yes. And then maybe I'll leave my mic on and you can hear when I'm screaming in the meeting that I have to be in, my crabbiness. All right. So we're going to complete, for the love of dog. It's on the top of the calendar, the one that the Google Meet link. You know which one I'm talking about, right? Yeah. Okay. All right. What's that now? We only have 2 minutes left. What? 1 o'clock. Yes. Okay. What is GRO? I forgot what I was going to write. Oh yeah, group. The first, the x squared and the x together. This is a process called. Oh, for the love of dog. Yes. What? What's wrong? Are you serious? I hit present and it was like spinning and said it was. Oh my! I swear to dog. Now it doesn't even have the present possibility in this. I hit it and I thought it was spinning and going. How can I do this? So you see the screen. Yeah. Maybe I'm just gonna write the. Can I write the example on this? Okay, here's what you do first. X squared. You put x. You know what? I quit. I'm done. I'm gonna shut down my computer. I'm gonna show completing the square as a separate thing, and then I'm gonna go ahead and jump out the window. Actually, it's okay. It's okay. I'm in the first floor. Everything's gonna be fine. But I'm done. I'm done. The internet has won today. The internet wins. Good job, internet. All right, we'll see you guys. Goodbye. I have to go to my meeting now in 3 minutes, and I got to recompose myself. See ya. That was great. That was great. Okay, so I think I'm going to try to screencastify and continue. So I know you don't see what just happened there. My Google Classroom, I'm trying to present, big lockdown, big, it just wouldn't work, and I couldn't teach my actual students. So now they have to listen to the end of this. Okay, so I'm going to recompose myself and actually teach the question. Okay, class, here's how you complete the square. You group x squared and x together. So I'm going to rewrite this. And then whatever you do to one side, you do to the other. So I'm actually going to set this up and teach you that this is only 2 steps when 1 is the leading coefficient. This is going to be easy, this one. By the way, whatever I do to one side, I do to the other. Yeehaw. Now, then, of course, well, why would it work correctly? The square. I know it's not a big deal, but now it's like a tire on the road. My tires are so bare right now. The smallest pebble is going to cause a major blowout. teaching high schoolers too. It's hard enough to keep their attention without these crazy things happening. All right. Anyway. Okay. And then of course I lost at 12. All right. I'll recompose myself. I think everything's gonna be okay now. Find your happy place. Okay. So here's what you do next. I'm going to move my face out of the way. Happy face. You take, now just do this. This actually has to do with the beginning of the bell work when I had people answer these questions. And it's right, there's the bell. 10 minutes till my meeting. Oh, I just can't wait. Can't wait. 3.5 hours. You guys ever see The Office? To the conference room. It's the whole basis of the ridiculousness of that show. Meeting. Okay, yeah, right here. So when I had someone take a 2 out, then factor, and you have a perfect square trinomial, and you write it as a perfect square trinomial, that is why we are going to complete the square. And again, to recombobulate what's going on here, I'm going to move my face again. Going to be in the way over there. You're just in the way, Mr. Samuelus. We're going to write standard form in vertex form by completing the square. Now, all kidding aside, you will have to complete the square when we have a later chapter. So this is a skill, wax on, wax off, just like in the Karate Kid. Why do we have to learn this? You'll find out. So what is half the middle term? It's this one. We're creating a perfect square trinomial by taking half of 12, which is 6, and then 6 squared is 36. Whatever you do to one side, you do to the other. You got to keep balancing the equation. And now what you've created is a perfect square trinomial. And you really could skip this step or do 2 steps in one, but I'm going to write this like this. And factor this. MA, you've created the perfect MA scenario. 6 times 6 is 36. 6 plus 6 is 12. This ends up being x plus 6 times x plus 6, just like in the bell work. And just like in chapter PR. And then you can subtract 36. What I'm telling you is, yeah, people that are going to get good with this is going to take 2 simple steps. In addition to the fact that you will have to complete the square later, and we will reference this again. So now that I've taken this in standard form and put it in vertex form, I can find the vertex super fast. -6 comma -25. Whew, oh, my heart's pumping. I feel alive. All right, next. Oh no, this one's different. So not only in step 1 are you going to group x squared and x together, that 3, you cannot complete the square right now. You cannot complete the square by taking half of 12 and then squaring it. You must take out, you better be ready for the 7th hour, take out numeric GCF. So I'm going to get this ready. F of x plus blank, whatever you do to one side, you do to the other. I'm going to group these right here and then take out that 3. And then the steps are the same. By the way, when I take a 3 out of a 12, it's a 4. Do not, I say one more time, do not take out a 3 from the 11. The 11 doesn't play this game. The 11's out here waiting for this to be subtracted. That's what's going to happen on the last step whenever I figure out what the number in the middle is. And you focus on this, and now it's not hard. What's half of the middle term? 2. What's 2 squared? 4. You've just created a perfect square trinomial. But whatever you do to the one side, you do to the other. Wrong! You did not add 4. I did that on purpose, like electrocution. Wrong. You don't put 4 there. You put 3 times 4. You actually added 12 to the right side. You added 3 times 4, not just 4. Okay, so just make sure you understand that's a 12 there. And then honestly, you could write the final answer next, because 3 times, what multiplies 4 and adds to 4? 2. 2 times 2, 2 plus 2, x plus 2 squared, simple factoring. And like I said, that was kind of like a redundancy there to have to write this one again. Oops. Okay, so 3 times 4 is 12, you added, and then we had 11 there. So yes, f of x equals 3 times x plus 2 squared minus 1. Okay, and then the vertex is -2. Oh boy, deep breaths just to survive, comma, -1. And then rise 3, 1, right. Can you believe I can compose myself and actually continue to teach the notes after I failed the Google chat with the students? Oh, what are they saying behind my back? And then I'm going to do this last one right here. Okay, so no words. Step 1, group the x squared and the x. 7 doesn't play. Step 2, take out a 2. That's how it's different than the beginning. And by the way, whatever I do to one side, I do to the other. Oh no, this should not be a problem, but it always is, these fractions. Remember, 7 doesn't play. Get away, 7. You got to stay outside the playground. Okay, so when I say complete the square now, so again, I took out a 2 out of 6. You take half of 3. Lexi Samuelis, the 10-year-old, can do half of 3 and not have to use the calculator and write it as a decimal. It's 3 halves. She's my 10-year-old at home. And then square it. So that's the process of completing the square. This creates a perfect square trinomial, a trinomial that ends up being a binomial times a binomial. And I'll show you how this factors. And then, of course, whatever you do to one side, you do to the other. Wrong! I just said you didn't add 9/4 to the other side. You added 2 times 9/4. Again, Lexi Samuelis can do this without a calculator. This is how you multiply fractions. And I say this not to be passive aggressive to my current students, to the students of the past, how poor they are with fractions because they use the fraction button on their calculator. Man, is he saucy today. F of x plus 9/2 equals, you expect me to factor this? Who do you think you are? If you notice, I tried to write this in each one, but then I erased it. Half of 12 is 6. Oops. Half of 12 is 6. Then I write 6 squared there to make this a perfect square trinomial. 6. Where's the other one? Where is it? Where am I going? What happened? Where is it? There it is. Half of 4 is 2. 2 squared is 4. 2. I wonder if that's a pattern. And it most certainly is. So you expect me to factor this and come up with a perfect square times a binomial squared? And it is. It's x plus 3/2 squared. 3/2 times 3/2, m. 3/2 plus 3/2, a. That is it. Whoo! Hey, I'm going to write this as 14 halves because that's what 7 equals, Lexi Samuelis. And now I'm ready to subtract 9 halves from it and write the answer in nice, perfect little form. All right. Good thing my blood pressure is ready to go for a 3.5 hour movie. Or what's I get it? This is a movie. 3.5 hour meeting. We've survived. Hopefully this video survives, and hopefully I don't get